Hello guys, this is Aim and welcome to the channel. And I know it's been a long I have posted a video on YouTube. But I promise you that there are many interesting videos which are being lined up. So I suggest you to stay tuned by subscribing. But right now, let's get started with the video. In less than a decade, Bitcoin's value has risen from many cents to around $4,000. But in meantime, there are hundreds of other cryptocurrencies emerging and even few equaling the Bitcoin's market value. As you may already know, Bitcoin and other cryptocurrencies are just internet money or e-cash. But thanks to online banking, if you just have an account in a bank, and right now you can make online transactions very easily for shopping or buying anything on the internet. But what makes Bitcoin and other cryptocurrencies different from this model of transactions? So the main specialty about Bitcoin is there's no central authority that authenticates and authorizes these transactions. But wait a minute, how is that even possible? And I'm sure there might be many more questions creeping out right now, like who validates it, why Bitcoin in the first place, and how Bitcoin works. But hold on, if you search Bitcoin on YouTube or Google, I'm sure you will find many videos and links which might give you enough knowledge. But something that sets this discussion apart is what I'm going to share with you in next few minutes. So the underlying technology under Bitcoin or any other cryptocurrency is blockchain. So blockchain is a great example of next level of internet, and it is a great example of decentralized network. Blockchain is a distributed ledger technology, refers to the protocol supporting infrastructure that allows computers in different locations to propose and validate transactions and update records in a synchronized way across a network. So these new systems based on distributed ledger technologies are often work without a trusted authority. And Bitcoin maintains a decentralized database based on consensus-based validation and cryptographic signatures. And also, these systems perform these transactions in a peer-to-peer fashion, and nodes in the network validates them across the branches and often known as blocks. So these blocks are maintained in a timestamp ordered and chained together, and hence this distributed ledger technology is often called as blockchain technology. So when I was doing research for the video, I have realized that there are 4 building blocks which make up the technology. So these 4 building blocks are linked lists, trees, encryption, and peer-to-peer networks. So if you're a computer science student and here for some inspiration, and I'm sure you'll get a lot of inspiration from this, because these 4 basic building blocks can build this cutting-edge technology. So each block in the blockchain consists of a lot of information. Obviously it should. But one such important information is it consists values of the previous block, and thereby it creates a chain of blocks and thereby creating blockchain. A block stores one or more transactions in the data block of the block. This chaining of blocks reminds us about a data structure called as linked list. In linked list as well, there is a root which creates the chain of linked list, or which is the head of the whole linked list. In the same way, the blockchain also has a initiate block, or also known as genesis block. A data block consists of a lot of information that we know, but another important information is it consists information about the transactions itself. And for that you see one Merkle root up there. So what is Merkle root? So Merkle root is a root value of the hash tree which is constructed. Merkle tree or hash trees. A hash tree is a simple binary tree. You might be knowing a binary tree, right? So how hash trees are constructed then? Hash trees has a leaf node. The leaf node actually contains the data, but all the non-leaf nodes consist the hash values of the leaf, and it is constructed like this. So hash trees have numerous implementations in a cryptographic system. It is used to verify the files transferred in between the computers, and in decentralized applications it is very important to know that if a file is tampered or modified in the way, and the attack is often known as man in the middle attacks or DOS. So in context of Bitcoin, Merkle trees use double SHA-256. So it's nothing but SHA-256 of SHA-256 of something. And what is SHA-256 in the first place? It is a cryptographic hash function. So generally a hash function is used to hide the actual data from any outsider. So hash data is nothing but a mathematical operations on a digital data. So this is generally used to verify the data integrity. So let's assume that you are downloading a file from the internet, and let's say it's very secure. So what do? You run a similar hash function on the downloaded file and you compare the hash function output with the expected hash function. If both turn out to be same, then your data is not tampered, else it is. And I must say that this technique is very complex, and if you want to know more about SHA-256 and SHA-512 and other hash functions, I'll link in the description below. You might be interested in knowing them. So why SHA-256? Because SHA-256 is computer hash functions on 32-bit word. Similarly, hash-512 is done on 64-bit words. So till now we have talked about data structures, what it stores, and as well as computation which is needed for performing cryptographic hashes. But where all this is done? Because this is not a traditional client and server architecture. This is a decentralized, as we have talked in the starting of the video. So where all it is done? It is done by all the nodes and all the peers in the network. The computation and the data and the memory is actually stored in the nodes, in all the nodes. In case of blockchain, all this transaction ledger is actually stored in all the nodes, and technically speaking not in all the nodes but in the a technical term called full node. So full node where all the data is actually stored, and it lends, so whoever is part of this network should lend his CPU cycles. Thereby all this hash function and performing this computation intensive tasks is actually possible. And this blows my mind, because all this time we were dependent on one particular server, but right now we can give our own machine and we can lend our own machine to become a server of its own and as well as consumer. So the blockchain also uses the same technology to enable this decentralized application. And if you want to know how each peer is discovered in the first place and nothing but how do you get started with Bitcoin, there is a technology called Bitcoin Core from where you get started. I'll link the necessary resources in the description below. If you're really interested, get started with them. And that's it for now. I have this much to say for this video, and if you have more and if you want to share more with this community, link any resources in the comments or share your thoughts in the comment, and I'll see you in the next one.